Welcome to module 9.7. In this lecture video, I'm going to show you how to solve what we so-called the linear inequalities in one variable. Now, before I do any example, I would like to explain a couple concepts. So what is so-called a solution set is referring to a set of all solutions. Okay, so think of the word set as like a big old basket, and we normally use brace to indicating the word set. So a solution set is basically a big old basket where I can put all my solutions in. So for example, if I have an x equal to 8, that means 8 is the only answer. So in my basket or in my set, I can just write my answer 8 in it. Now, since we are dealing with inequality, x greater than 8 actually means we will be looking for all the numbers that are greater than 8. So we will need, so that's the reason why we use a solution set to include all those numbers that are bigger than 8, which is actually infinite, because there are infinite numbers that are greater than 8, like 8.1, 8.11, 9, anything bigger than 8 is actually it will be my solution set. So the solution set, or sometimes we call them set builder notation, is going to be the set. All right, for this x greater than 8, we will say this is a set of all x's such that, the slash means such that all the x's are greater than 8. Okay, that's how we actually read the solution set. So another way we can describing all these numbers that are greater than 8 is using something called the interval notation. Okay, in this class we will use interval notation for all the solutions. Okay, within a certain interval using inequalities. So whenever we use inequalities, we can use this thing called the interval notation. In college algebra, we will use interval notation for domain and range. All right. Now, my note up here says always read the inequality from where the variable is. So as you can recall, the list of inequality, and I'm not going to say what they are because it really depends on which side you're reading from. So for example, if I say x is greater than 8, all right, read from the variable, this says x is greater than 8. That means I'm looking for all the numbers that are bigger than 8. But if I was write this way, is that the same thing? If I read from the variable x is greater than 8, which is same as x greater than 8. So as long as you read from the variable, okay, you can actually read this inequality properly. All right, we will always write our interval notation from the left to the right of the number line that we are going to graph here in a minute. Always use brackets for the equal to, greater than, less than, or equal to, using brackets. Bracket means I'm including that number as part of my solution. We will use parentheses for the inequality that does not have equal to, and we will also use parentheses for my infinity signs. All right. So rather than explaining all this, okay, I'm gonna slowly I will show you how to read all this, but let me just using my x greater than 8 for example real quick here, and I'm gonna draw something in the number line. So let's say after I solve my equation, my answer says x greater than 8. On the number line, let's say 0 is here, 8 is here. The inequality is looking for all the numbers that are bigger than 8. Numbers that are bigger than 8 got to be to the right of 8. Since my inequality have no equal to, that means I will use parentheses. Okay, parentheses, all the answer to the right side of 8. How right do I go? I got to be going to infinity. Okay. So once you're able to graph on the number line, then we can easily write our interval notation just by looking at the graph. So my interval notation got to be parenthesis starting at 8, but not including a comma. Comma means the word to. My answers are from 8 to infinity, but I do not include 8. That's why I use a parenthesis. All right, that's how we write the interval notation. Now let's do this the other way. X is less than 8. X is less than 8. So let's say 0 is here, A is here. X less than 8 means looking for all the numbers that are smaller than 8. All the numbers that are smaller than 8 is to the left side of A. How left do I go? Got to be going to negative infinity. All right. So since my inequality does not have equal to, I will use parentheses. But now when I write interval notation, I got to look at this number line from left to the right. Left to right means small to large. So where my answer starting from? My answer starting from the small left side, which is negative infinity, comma means 2. My answers are from negative infinity to 8, but I do not include 8. So if I will add the equal to part, then my 8 will be using a bracket instead of parentheses. Okay. Now these first 3 things here, okay, it's just trying to explain to you how to use open and close interval, bracket or parenthesis. But these inequality, I will explain in a different section. Okay, there's a certain way to read these. Okay, so when we get there, I will explain to you how to read this. So basically, I was trying to explain to y'all how to read open interval and closed interval. Now, solving linear inequality is just like solving linear equations with the equal sign. We got to identify terms, distribute if needed, combine like term on each side. Then we will move all the variable term to one side and everybody else to the other side, and make sure you change the sign when you move a term across the equal sign. Combine like term if needed, and divide both sides by the coefficient. So the only difference is right here at the very end. For inequalities, if the coefficient is negative, okay, if I ever need to divide both sides by a negative coefficient, then I got to change the inequality to the opposite one. And here's the reason why. If we say 2 less than 3 is true, then what happens if I multiply both sides by -1 or divide both sides by a -1, by a negative number? Then I will have -2 and -3. But this time, who is actually bigger? The -2 is bigger. So that's the reason why when I divide both sides by a negative coefficient or multiply by a negative factor, my inequality got to be changing to the opposite one. Okay? Just keep that in mind. We need this concept once in a while. So let's give this a try, okay? Write the solution using interval notation. Okay, so this step number 1 is actually writing out the interval notation. So I kind of do need you to know how to do this just all together at one time and then writing your answers separately. So since this equation only has 2 terms, all I'm going to do is divide both sides by my coefficient. Now, the coefficient is positive. It's not negative, so my inequality stays the same. So that will be x greater than -4. All right, that's not interval notation yet, because now I'm looking for all the numbers that are greater than -4. That means my solutions are everything to the right-hand side of -4. Since my inequality does not have an equal to, I will use a parenthesis, open interval. That means -4 is actually not one of my answers. I have an infinite number of answers, but negative 4 is actually not going to be one of them because I'm not including it because there's no equal to. So I'm using an open parenthesis to indicate negative 4 is not being included. Kind of use the negative 4 as a reference, okay? So now, looking at this graph, I can write my interval notation, which is what the answer is for step number 1. I'm starting at negative 4 using parentheses. My answers are from negative 4 using parentheses to, that's what that means, to all the way to the right to infinity. Okay, so that will be my interval notation answer, and this is actually my graphing solution. So on the homework, you'll be choosing, you have choices, parenthesis, 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 bracket, bracket, parenthesis, and such. So you will actually pick parenthesis, parenthesis. Okay. All right, let's try another one. So this time, my negative 4x is greater than negative 36. So if I will go ahead and, since I only got 2 terms, I can divide both sides by negative 4, which is a negative coefficient. So my inequality now got to switch over, which will be x is less than 9. All right, another way of doing this, which is the way I normally prefer, so I don't have to worry about switching inequality. And you can do either way, it's fine. Since my variable term is negative, I can move this term to the right. That means move the negative 36 back to the left. So moving term is not dividing by coefficient. So inequality stays the same. Negative 4x come to the right, become positive. Negative 36 go to the other side, become positive. So now when I divide both sides by a positive 4, then my answer will say x, what? How do you read this? X is what? Less than positive 9. Just like here on the left side, x is less than positive 9. If I read from the variable, this is also say x is less than positive 9. All right, so let's go to the graph real quick before we come back to interval notation. Looking for numbers that are less than 9. So 9 is about right here. So looking for all the number that is less than 9. That will be to the left of it. All right. Since my inequality does not contain equal to parts, so I will use a parenthesis. Okay. So now, by reading this graph from left to right, my interval notation got to be the solutions are from negative infinity from the left all the way to positive 9, which I'm using another parenthesis. All right. So just a quick introduction of using how we can use interval notation to describing our solution for interval for our inequality. And also, we are introducing the set notation. The next time I will use a set notation is probably dealing with an equal to, okay, with an absolute value. All right, in the next lecture video, we will solve more linear inequality. And that will conclude this video. Thank you for watching.